Good morning, everyone. Today we're looking at Unit 1, Lesson 8, Functions and Formulas. So, formulas in mathematics, science, and business may be represented mathematically by polynomial functions and other functions such as exponential functions. So there are formulas that we could substitute into formulas for volume, for surface area, if we were trying to calculate the interest on an investment, if we were trying to calculate velocity, lots of formulas where we have variables and we have known amounts that we can substitute into. So today we're going to talk about strategies for how we solve these formulas. So the first strategy we could use is substitution. And with substitution, if we chose to use that to solve a formula, what we're going to do is we're going to substitute the known values directly into the formula and then solve for the unknown. Our other option would be to rearrange. So when we rearrange a formula, we first rewrite the formula in terms of the unknown. So we isolate for whatever the unknown is and then substitute in the values. So we're going to look at those two different strategies in relation to the volume formula of a cone. So the formula V equals pi r squared h divided by 3 is used to determine the volume of a cone with radius r and height h. Determine the volume of a cone with radius 5 and height 7 centimeters. And we're going to round our answers to one decimal place. So we would say we have r equals 5 and h equals 7. So our volume formula again is V equals pi r squared, so in this case we have 5 squared, times our height, which is 7, divided by 3. So 5 squared is 25, 25 times 7 is 175, times pi divided by 3. So if we were to calculate that, we should get 183. Let's just write that V equals, we have our volume is equal to 183.3 centimeters, and a volume is always in cubed units, so centimeters cubed. So that's just a straight, we've been given all the numbers we need to plug right into our equation, nothing to isolate there, we're just trying to find volume. So we've already isolated the unknown because it's the original formula. We're going to look at, if we're given some amounts that aren't all on the right side of the formula, how can we work to find that unknown? So determine the height of a cone with a volume 35 centimeters cubed and a radius of 4. So we've already been given our volume. Here. They're asking us to determine the height. So we know that the radius is 4 and that the height is what is unknown. We don't know what it is. It says sub in your known values and simplify. Label the variable and the constant. What type of function is this when we do this? So if we're labeling our variable and our constant, well, our variable is going to be whatever is unknown. So right now we don't know what our height is. So we would say that that's the variable. Our constant in this case would be our known value. So our radius, we already know. So that would be our constant. So if we use that formula for volume of a cone, V equals pi r squared h divided by 3. We're going to sub in our known values first. So we're going to use this a strategy of substitution. So our volume is 35 and our radius is 4 squared times h divided by 3. Okay, so we've substituted in our values. We don't know what h is yet. So we're going to simplify. So we subbed in our known values, and now we're going to simplify as much as we can and then solve for our unknown value. So 35 equals, so we have pi 4 squared is going to be 16 pi times h divided by 3. Okay, so I'm going to start isolating for h now because that's what I'm trying to find. We're trying to determine what's h. So we're going to start isolating for h. So I'm going to start by multiplying my 3 over to the other side. So we'll have 35 times 3 equals 16 pi h. That's 105 equals 16 pi h. Okay, now I can divide both sides by that 16 pi. I'll just finish that over here. So we'll have 105 divided by 16 pi equals h. And if we were to calculate 105 divided by 16 pi, we'd get 2.09 equals h. And we could say, therefore, the height of the cone is 2.09 centimeters. But let's go back and answer that question that was asked of us. So we subbed in, we simplified to find h, we labeled our variable and our constant. What type of function is this? So what type of function? So when we got to the point where we isolated h, so right here, we have h isolated. So we have h is equal to 105 divided by 16 pi. These are all numbers. I know sometimes we might think pi as a variable, but pi is a known amount, right? It's 3.14. So if we have h is equal to some number, then this is a linear function or a linear relation. Right? Think about if we had y equal to 5. We know that's just a horizontal line, right? But it's still a line. So when we have a variable equal to any constant, any number, that's just a linear function. So we created a linear function here when we had our radius value but didn't know our height. So let's look at another example. So determine the radius of a cone with the volume of 50 centimeters cubed. So they gave us our volume again, and we have a height of 3. So this time h equals 3 and our radius is unknown. So if that's the case, then we would say that our height is our constant, because that's our known value, and our radius is our variable. That's what we're trying to find. So this time we're going to rearrange the function. So instead of using substitution, we're going to rearrange this time. So let's rearrange our function in terms of r, and then we'll sub in our known values and simplify. So once again, our formula for volume is volume equals pi r squared h divided by 3. So this time we're going to substitute, or we're going to isolate for r before we sub anything in. So I'm going to multiply, I'm going to start by bringing this 3 over here. So I'm going to have 3v equals pi r squared h. And then I'm going to divide both sides by pi h. Right, so then I have just my r squared left there. So 3v divided by pi h equals, and then the pi's on this side cancel out, the h's cancel out, and you're left with r squared. Okay, so we could continue to get rid of that power of 2 on my r, but I'm going to sub in from here. So let's sub in h equals 3, and then our volume equals 50, because we have r all by itself. So into the equation we just rearranged, we'll do 3 times my volume, which is 50, divided by pi h, so 3 times pi, which is going to equal r squared. Our 3's are just going to cancel out, and we're going to be left with 50 divided by pi equals r squared. If we simplify 50 divided by pi, we're going to get r squared equals 15.92. And then finally, we're just going to take the square root of both sides to isolate my r. And remember, if we're taking the square root, that's a positive or an even exponent. So the solution will be a plus or minus. And we're going to get 3.99. So therefore, the radius is 3.99. Because remember, the negative is not possible. Can't have a negative radius. But something to think about here. So we labeled our variable and our constant. We come back to that question. It says, what type of function is this? So you can see here at this point where we created this equation, we're going to have a quadratic relation, right? We have r squared, which is a quadratic, is equal to, and then 3v divided by pi times h. So we've created a quadratic here because we have it set equal to that r squared amount. So we're just going to kind of summarize what we did today with the substituting and the rearranging. So which variable in the formula would you need to set as a constant to generate a linear equation? So let's rewrite the formula we were using for volume of a cone. So volume equals pi r squared times h divided by 3. So initially we set the radius equal to a constant. So when this was a constant, we could simplify that square root. So all we had was an exponent left that was raised to a power of 1. So it created that linear relationship. So let's just say if you set radius, underline, if you set radius equal to a constant, the resulting equation will have a linear relationship between the other two variables that were in this situation, which were your height, or your h, and a volume, or v. Okay, which variable in the formula would you need to set as a constant to generate a quadratic equation? So remember, once again, v equals pi r squared h over 3. So when we set our h to a constant, right, then that still left us with an r squared, and that r squared created a quadratic relationship. So if you set height, so height equal to a constant, the resulting equation will have a quadratic relationship. We'll have a quadratic between the radius, which was r, and volume, v. Remember, because we have a squared in there, there should be two solutions, but both might not be possible. Okay, so if we want to generate a quadratic relation, we have to set the variable that's to a power of 1 as a constant and leave the variable that has a power of 2 as the variable, because that creates a quadratic. If we want to create a linear relationship, then we have to set the variable that has that power of 2 as a constant, because it gets rid of the power of 2, and you're just left with a variable to a power of 1. Okay, so that's it for your note today.